Prim's algorithm. So under Prim's algorithm, what will you do? So algorithm Prim's. So what are the four parameters we are taking? Cost parameter, E, number of edges, and T. Cost is the adjacency matrix, E is the number of edges, N is the number of vertices, and T is the tree information which you will add. So what is the tree information? The tree information is which is tree, which is for given graph there are 1 by 6, 3, 4, 5, 6. So 6 rows, 2 columns. Is that clear? Sir. So what is the first line? Yeah, please read the first line. Let k comma l be the min cost edge in a given graph. In a given graph, k comma l. So what is the k comma l? Let k comma l be the min cost edge. Min cost edge in the graph G. In the given graph G, what is the min cost edge? Please check it, please, and tell me. What is the minimum cost edge? K comma L. 1 comma 6. Yes or no? What is the min cost edge there? 10. So what is K? 1. What is L? 6. Okay. Now, what is the second step? Now you update the minimum cost. So min cost is equal to cost of K comma L. Cost of K comma L. So we will also update the minimum cost here. So the minimum cost value will be what? Initially 0. Now it will become 10. Now we will also update the tree information. T of 1 comma 1 is equal to K, and T of 1 comma 2 is equal to L. So we will also update 1 and 6. Is that clear? Every line I am writing and updating. Now how many edges you have added in the tree? 1 edge you have added. Remaining 5 edges you have to add. Before adding it, you also want one more vector which is near vector. We are writing one vector called as near. What do you mean by near? For every vertex, which vertex is near, we have to update. Now for remaining all the vertices, whether 1 is near or 6 is near, you have to update. So for help purpose, you also draw the graph which will help you. 1, 2, 3, 4, 5, 6 and 7. Can you please tell me 1 to 2, 1 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, and so 1 to 2 cost please? 28, 2 to 3, 16, 3 to 4, 12, 4 to 5, 22, 5 to 6, 25, 10, one more edge, 2 to 7, 1 more edge, 7 to 5, 24 and 7 to 4, 18. Now take the graph and please substitute. Okay. Now you have to update the near vertex also. So this is what tree information. This is what near vector. Now you have to write if. So for all the vertices you have to update the near. For I is equal to 1 to n, do what you need to do is you have to update the initialize the near. For all these vertices, whether 1 is near or 6 is near, you have to update. So very simply, what will you check? If cost of I comma, you can write K or L both in there. Okay, so I comma L less than cost of I comma K. If the condition is true, who is near? L is near. So near of I is equal to L. If the condition is false, near of I is equal to K. Now you please check it. Now for all the vertices. Actually, one line you have missed here. Already you have added the first edge, right? Okay, so first update it, then we will change. Okay, yeah. So near of 1 comma 1 less than 1 comma 6. Please check it. 1 comma 1 cost is what? Infinity. Infinity less than some value. Condition is false. So automatically for 1, 6 is near. As per the code. Next, 2 comma 1 less than 2 comma 6. Sorry. Yeah. So 2 comma 1 less than 2 comma 6 please. Please check it and tell me. 2 comma 1 cost. 2 comma 6 cost. Yeah. 21 less than infinity. Condition is true. So 1 is near. Next 3 comma 1 less than 3 comma 6.
True అయితే L false అయితే K true అయితే L and false అయితే K అంటే 1 and 6.
Yeah. Okay, no problem. Right. So condition is true means 6. Okay, done. Next 3 comma 1 less than 3 comma. Okay, మనం ఇట్లా రాస్తున్నామా? Okay. 3 comma 6 less than 3 comma L.
Yes sir.
Yeah. So 3 comma 6 less than 3 comma L. Please check it. 3 comma 6 is what? Infinity. 3 comma 1 is what? Infinity less than infinity. False. So K will be near. Next 4 comma 6 less than 4 comma 1. 4 comma 6 infinity. 4 comma 1 infinity less than infinity. K. So K value is what? 1. 5 comma 6 less than 5 comma 6. Sorry, 5 comma 6 less than 5 comma 1. 25 less than infinity. Condition is true. If the condition is true, L is what? 6. Next, one more time. 6 comma 6 less than 6 comma 1. 6 comma 6 infinity. Infinity less than 1. False. False means what? K. K value is what? 1. Next, last time. 7 comma 6 less than 7 comma 1. 7 comma 6 cost.
Infinity.
7 comma 1 cost. Infinity less than infinity. False. K value is what? 1. Now near is red. Now already you have added one edge, right? After coming out you do it. Near of K is equal to 0 and near of L is equal to 0. So what are the edges you have added? 1 is 0 and 6 is also 0. This is what. So what you have done so far, this is adding the first edge. This piece of code is what? Initializing the near. Now you have to add remaining n minus 1 edge you have already added. How many edges will be in the spanning tree? N minus 1. 1 edge is completed. Remaining n minus 2. So what will you do? For I is equal to 2 to n minus 1, do. Find out the remaining 5 edges. So what you have done for finding out the remaining 5 edges, please check it. So you please check it. I is equal to 2 to n minus 1. So find out the remaining. Now this line is a very important one. Let J be an index such that near of J not equal to 0 and cost of J comma near of J is minimum. That line will play a key role. Let J be an index such that let J be an index such that near of J not equal to 0 and cost of J comma near of J is minimum. Now please find out which values near of J is 0, 1 and 6. Other than 1 and 6, find out remaining values. So 2 comma 6, 3 comma 1, 4 comma 1, 5 comma 6, 7 comma 1. 2 comma 6 cost. 2 comma 6 cost. Infinity. 3 comma 1 cost. Infinity. 4 comma 1 cost. 5 comma 6 cost. 25. 7 comma 1 cost. Infinity, yeah? Sure. So out of these, which one is minimum? 5 comma 6. So who is J now? 5 is J, 6 is near of J. So let J be an index such that near of J not equal to 0 and cost of J comma near of J is minimum. Who is minimum? 25 is minimum. So who is J here? 5. Very good. Is that clear? This line will make the entire algorithm finish. Let J be an index such that near of J not equal to 0 and cost of J comma near of J is minimum. Now you got the next edge. So what you need to do? You found the J, right? Now update the second edge, third edge, fourth edge, fifth edge in the same line. So now please update. So what is I value? If you don't remember, what is I value? 2. So what will you do? T of I comma 1 is equal to T of I comma 2 is equal to, you found it. What is T of I comma 1? J. What is J here? 5. So 5 will be written. Next, near of I comma 2. So T of I comma 2 is equal to what? 6. Who is 6? Near of J. Near of J is what? 6. Now we have added the second edge. Now what you need to do? You have updated the edge information. Also update the cost information and update the near. Only for this step I will explain. Next step we will explain the some other type. So what will you do? Min cost is equal to min cost plus cost of j comma near of j. So already what was the minimum cost? 10. Min cost plus cost of 5 comma 6 is what?
25.
25 plus 10, 35. Now this is completed. Is that clear? So min cost is updated. Now already 1 is included in the solution, 6 is included in the solution, 5 also included in the solution. That's why near of j is equal to 0. So near of j will become 0. Is that clear? Now when you have initialized the near vector, you have calculated whether 1 is near or 6 is near. Now one more vertex came into the competition, 5. Now you update other than 1 and 6 whether 5 is near or not. So what will you do? Update in the near code. Is that clear? Yeah. So how will you update? For k is equal to 1 to n 2. Very simple. Already existing cost you will update with latest cost. No problem. Is that clear? So old cost is what? Very simple. Now you please check it. For all those near of k not equal to 0, near of k comma near of k, old. Near of cost of k comma j, new. If the condition is true means what? You update the near. Is that clear? So for those all values you update the near so that you will get the next value. Now of course code execute JSC we will stop. Now please tell me, please substitute please. K is equal to 1 to n, near of k not equal to 0, cost of k comma near of j. Okay. So if near of k not equal to 0 and cost of k comma near of k, if the condition is greater than cost of k comma j. Now please check it for all the values if the condition is true. K, for which value is k not equal to 0? Okay. Now you please check it. Cost of k comma near of k 2 comma 6 greater than cost of k comma j 2 comma 5. Now please check it. 2 comma 6 cost enta? Infinity. Greater than 2 comma 5? Infinity greater than infinity. False. So if the condition is true, you will update. If the condition is false, don't update. Condition is false, don't update as it is. And 5 is not near. For the next value, please. For the next value. 1 is complete, 2 is complete. Next, 3 comma 1 greater than 3 comma 5. 3 comma 1 cost? Infinity. 3 comma 5 cost? Infinity greater than infinity. False. Don't update. Next, 4 comma 1 greater than 4 comma 5. 4 comma 1 cost? Infinity greater than 4 comma 5 cost? 22. Infinity greater than 22. Condition is true. Immediately will you update near of k is equal to j. So who is j? So for 4, 5 is near. For 4, 5 is near. Now for next statement. For 5 and 6 we don't calculate. Why? Because near of k not equal to 0. For the last time, 7 comma 1 near of k comma near of k greater than 7 comma 5. 7 comma 1 is cost is what? Infinity. 7 comma 5 cost is what? 24. So definitely for 7 who is near? 5 is near. So this piece of code is doing what? Update the near. Now after updating the near, what will you do? Once again add the third edge, fourth edge, fifth edge, sixth edge, which will get the minimum cost spanning tree using prims. So under prims always if you observe, it will get connected tree. Is that clear? So thank you so much. See you in the next class. Don't worry about the video. In one attempt we won't get it. One or other disturbance will come. We will do it in the next time. Thank you so much. See you.